Hello, welcome to Math with Beth. And we're going to look at first derivatives and how to use them to find relative max or mins and also to sketch graphs. So there's a lot of wording in the textbook on this, so I'm going to try to make it a little easier to understand. So basically with first derivatives, if you find out that the first derivative is positive for a certain interval, then the graph must be increasing over that same interval. If it's negative on an interval, then the graph must have been decreasing. So it relates to the slope of the graph. A critical value is what you find when you set either the equation equal to 0 or if the derivative does not exist at a certain point. So when we get into rational functions where there's x's in the bottom of fractions, sometimes we will have to find out where the function does not exist. So critical values are points that could be max or mins. And the way you will know if it's a max or min is the first derivative test. So first it's saying if it has a relative extrema, it will be at a critical value. So again, the critical values are where the derivative equals 0 or does not exist. So the first derivative test tells you to find these critical values and then test each section to see if it's positive or negative, because you are always going to have a relative min if it is negative to the left and positive to the right. In other words, if the graph is decreasing on one side and then increasing, that point must be a relative minimum. And then the opposite is also true. You're going to have a relative maximum if it is increasing on one side and then decreasing. So that should make sense because decreasing and then increasing would look like this, where if a graph was increasing and then decreasing, it would look like this. So this would be a relative min. This one would be a relative max. So it's a lot of wording to basically just say this. So let's do an example to see how it works. So if this was my equation and I wanted to find any relative extrema, I'm first going to find my derivative. And this is a simple derivative because I can just use the power rule. So it becomes 6x squared minus 6x minus 12. So now to find the critical points, since there is nowhere this would be undefined, I just have to set it equal to 0 and solve to find any critical points. So I can factor out a 6, and then I can factor more to x minus 2 and x plus 1. So setting everything equal to 0, I get 2 and -1 as my critical points. So I'm going to put those on a number line to show that those are the 2 points that could be either relative max or relative mins. So now I'm going to test a point in each of these 3 sections into the first derivative to see if it's positive or negative. So over here, I could test something like -2. If I plug -2 into the first derivative, so you can do it here or here. It's a little easier for me to think of it here because I can just think, okay, 6 is positive. If I plug -2 into here, I'll get -4. So that's a positive times a negative. If I plug -2 into here, I'll get another negative. So overall, a positive times a negative will be positive. If that's confusing you, just take the -2 and plug it into the whole thing and see what number you get. You'll see that you'll get a positive number. I'm just kind of taking a shortcut. In the middle, I'm going to choose 0. So if I plug in 0, I can see I'll have 6 times -2 times 1. So that will be a negative. And over here, if I pick something like 3, I will get a positive. So I'm doing a shortcut by just kind of thinking about the overall signs, but you don't have to do that. You can pick up your calculator and plug it into all the x's and see what you get. But basically, because this is increasing here and then decreasing, I know this one's going to be a max. And because we're going down and then up, this one will be a min. So I have a relative max at -1 something and a relative min at 2 something. So now just be careful. Once you know where the max and min are for the x's, the way you get the y's is make sure you go back to the original equation, not the derivative. So I'm going to plug -1 into the original equation, and if you do that, you will get 19. And if I plug 2 back into the original equation, I would get -8. So those are my relative extrema. So let's do that one more time just with a little fancier equation here. So to find the derivative of this, I need the chain rule. So I bring that 2/3 out front, and then I subtract 1 from it, times the derivative of the inside, but that's just 1, so I don't really need to do that. And the derivative of 1 would be 0. So this is my derivative, but keep in mind that that really means this, right? 2/3, and then this really means the third root on the bottom of the fraction. So in this case, if I set it equal to 0, I get no answers from the top. But if I set the bottom equal to 0 to see where it would be undefined, I will get an answer. So if I divide by 3, I'm still here. If I now cube both sides, I'm here. So 2 is the only possible critical point. So I just need to plug in a point to the left of 2, so I could plug in 0. And I see that that would give me a negative, because it would be a +2 over a negative down here. And if I plug in something like 3, 3 minus 2 is 1. So all of this times 1, it would all still be positive. So if we're going down and then we're going up, this is a min. So we only have a relative min at 2 something. And again, make sure you go back to the very original graph to plug that in. And 2 minus 2 is 0. So really I get 0 plus 1. So 1. So that is it for those. So now let's do one where we're going to find out everything and sketch the graph. Okay, so I'm going to start this out the same way. I'm going to first find my derivative and find my critical points. Set that equal to 0 and factor. So you end up getting 0 and 2 for your possible critical points. If I plug something over here into the derivative, I would get a negative. If I plug something like 1 in, I would also get a negative, because that's 4 times 1 times -1 in here. So 0 is not a relative max or relative min, because it's not changing from going up and down. And if I plug in something like 3, I would get 4 times 3 squared, which is 9, times 1. So that would be positive. So this one is something. So remember, if you're decreasing and then increasing, this is going to be a min. So plug these points in just to see what's going on. So if I plugged in 0 at the very beginning, I would get 0. And if I plug in 2, I would get -16/3. So if I use that information to sketch, so we're around here. Remember, we are decreasing till here, and then still decreasing till here, and then increasing. So the graph's going to look something like that. Let's try one more. So this one is definitely a little harder as far as finding the derivative. So make sure you're using the product rule. So x squared times the derivative of e to the negative x, which is e to the negative x, but then times the derivative of negative x, which is -1, plus e to the negative x times the derivative of x squared. So we could factor out, if I want to set this equal to 0, I could factor out an x and an e to the negative x, and that would give me negative x plus 2. So if I set each of these equal to 0, I would get 0. If e to the negative x equals 0, that can't happen. And if negative x plus 2 equals 0, I would eventually get 2. So 0 and 2 are the numbers we are looking for our plug-in to the first derivative to see if it's increasing or decreasing. So if I plug in -1, that would give me -1 times e to the 1 times -1 plus 2. So that would be a positive times a positive times a negative. So that is a negative. If I plug in something like 1, I would get 1 times e to the -1 times -1 plus 2. That is a positive times another positive, because remember, e to the -1 is really 1 over e. It's not a negative number. And then -1 plus 2 is also positive. So all of these are positive. And then if I plug in something like 3, I'm getting 3 times e to the -3rd times -3 plus 2. So again, a positive times a positive, because this is just 1 over e to the 3rd. But then here's a negative. So that's a negative. So we have a relative min here, because we're going down and then up. And here we're going up and then down. So we have a relative max here. So plug 0 and 2 into the original equation to see what you get. If I plug in 0, I'm going to get 0, because 0 squared is 0, so it doesn't even matter what's happening here. But if I plug in 2, I'm going to get 4 times e to the -2. So 4 over e squared. If you put that in your calculator, that's about 0.54. So let's sketch a graph. So at 0, 0, something's happening, and at 2, about a half, something is happening. So we are decreasing till here, then increasing, then decreasing again. So something like that. So that is a general idea of how to use the first derivatives to help you find relative min and max, and also to sketch graphs. Let me know if you need any more help or have any questions. Thank you.